influence lines. We have this beam, A, B, C, fixed at A, internal hinge at B, and roller at C. The question is, determine the maximum negative moment at A and the maximum positive shear at D due to uniform dead load equal 200 pounds per feet and uniform live load equal 150 pounds per feet. Again, for influence line, the question when we have influence lines, two steps. First step, we construct the influence. Second one, we place the loading to maximize. So first we need to construct or draw the influence line for the maximum negative moment at A. Then we see where is the location of the load that will maximize this. Then we need to draw the influence line for the maximum positive shear at D. Then we see how we place the load to maximize. The load, we have uniform dead load, 200 pounds per feet. Where is the location? Where is the location of dead load? Everywhere. Now we have uniform live load 150 pounds per foot. Where? Varies. Can have any length. You may have here, you may have nothing in here. You may have it everywhere. Here. Varies length. Live load. Now we can have one person in this room. We can have everybody in this room. We can have one car on the bridge, سيارة, or full car. Live load. Live load means can have any length. You will see. You have to draw the influence line and see the location. Just wait. Stand. But the live load can have any length. So what's the question? First one. So we draw the influence line for the moment at A. Influence line for the moment at A. When you have a question like that, you have to split the beam. You have to split the beam into two segments or two components. This one and this one. Yeah. لا تسألني عن ايش وانا بحل الاشي. I'm solving this problem. When we have overhang, we solve the overhang. خليك هون هيك فكر بالاوفرهانج. We have to split the beam. We have a reaction here and a reaction here and a reaction here and a reaction at A and a moment at A. And A positive in which direction? This is positive MA. This is what we want. The influence line for the positive MA. It's the same as the direction. And this is the reaction. The internal moment is the same on the left. They are the same. So this is what we want. Okay. This segment has 4 unknowns. We know this is 0, but we have 4 unknowns. So every time, and كل مرة, we have to solve this, then come back here. And we have to find this one from this segment, then come back here. Okay, now we place the unit load at some point. This is the unit load 1. When the unit load is here, this is 1. How much here? Is there any load here? Nothing. 0 and 0. If this is 0 and this is 0, how much this one? 0. So the moment is 0. Now when the unit load is here now, the one is here. Just to the left of this one. Think. How much this one? 1. منين جبت ال1? في load هون? Both are zeros. So this is 0 and this is 0. So how much this one? 0. So how much the moment? Minus 5. 1 times 5 minus 5. So it's minus 5. And we know this one is straight segment. When the
اعتبروش على اليمين صفر.
ما اعتبرناه هو طلع معنا. مين قال لك انا اللي اعتبرته؟ منين قال لك انا اللي اعتبرته وهو صفر؟ كيف يعني منين بدك تجيبه؟ وين؟ هيصمم the one to equal to zero صفر. انا ما اعتبرته. It is zero.
بس مش عندي رياكشن لفوق فوق واحد على اليسار قصدي.
هون؟ ما هو نفسه. إذا من هون صفر وهون واحد يعني؟ له شخصيتين يعني؟ ما هو صفر من هون.
يعني الاعتماد اللي على اليمين.
هذا محمد وهذا محمد. محمد هون صفر وهون واحد. It acts as a cantilever يا اسمه. لا تفهم الحالة. This guy هذا الشخص the same as this guy. إذا بتقول هذا واحد, if you say this is one, it means this is one. It means this is unstable. You look here. Sum of the one term equal to zero. This is zero. It means this is zero. واحد times this minus 5. Now jump here. Now it's one. بس راحت الواحد من هون. You don't have the one here. So it's one down. Still minus 5. And when it's here, how much this? Zero. How much this one? Zero. One here and one here and this is zero. Zero, zero.
نقلنا الواحد عند الرولر عشان يطلع زيرو.
هاي واحد حرف مش واحد. How much this one? Zero. If this is zero, how much this one? Zero. How much that one? Zero. هاي influence line. All negative. يعني at any location on the beam, at any location, any load on the beam will cause negative moment at A. Fish location, there is no load at any location on the beam that will give me any positive moment. So now, to maximize, we have the dead load. The dead load we cannot avoid it. On the whole area, this is the dead load, the location of the dead load. Everywhere. Right? 200 round air full. So how much moment will give me? Look. Look. If we have one load here at this point, how much the moment here? Minus 5. And if we have 1 unit load standing here, this minus 5 means the moment at A will be minus 5. If we have another one here, the load times this. Another one here, the load times this. So, it will be this times this. 200 times this. 200 times this. 200 times 5. 200 times this. It means 200 times the area. So this will be 200 times the area is half times 15 times 5. Negative. Right? Half times 5 times 15. The area. So where you place the live load now? يعني عندك الاوبشن. You have the option to put the live load here or here or here or ما تحطوش or everywhere. Will give you more area, more negative area everywhere. So also the live load must be placed so minus 150 times half times 15 times 5. So this is the maximum moment that those loads can generate on the beam. When both of them maximum negative moment at A, when the full beam is loaded with both of them. يعني بس يكون اثنين عليه all the load. How much? What's the unit? Pound feet. Pound feet.
دكتور طيب هو طالبها عن ايه ليش هيك اخذنا؟
I win now. What's the second one?
max positive shear.
So we need the influence line for V at D. For V at D. Here. positive shear at D. Again. So our section we have to have this for the reactions. And we need, this is D, right? We need this. This is D, right? VD, how? Positive how? Up. This is VD. And I need this one. VD, this one. What's this one here? What's this? This is the reaction at C. C. So, look. We don't need this one. So, VD equal minus RC. إلا إذا كانت اليونت لود هون. Except if we have the unit load here. يعني from here to here, VD equal minus RC. If the unit load is here, VD equal 1 minus RC. Good. So, اللي بدنا إياه, all what we need to do is RC. Good. So, VD, if the unit load is from A to D, VD equal minus RC. And VD equal 1 minus RC. Okay? If the unit load from D to C. Good? So let's see. Look. So this is RC. And this is the something here and something here, and we have this AY and a moment here. Look, if the unit load is here, look here, just watch me. If the unit load is here, look, if the unit load is here, or here, or here, or here, or here, how much RC and this one? Nothing. There is no load on this one. Both are 0. So how much VD?
0.
So this is 0. Regardless. Any load here on this segment, أي load هنا ما بعطينيش shear at D. Will not develop a shear at D. Now look now. If we have it here, how much this one? 1. How much RC? So VD is 0. Still 0. Now, if it's in the middle, right at D, here. How much this one? 0.5 and 0.5. So VD equal minus 0.5. Minus RC. Cross D. Now, it means the unit load is here. So VD equal 1 minus 0.5. When it goes to here, RC equal 1, and there is 1, so VD equal 0. 1 minus 1, 0. مش حكيت لكم مرة didn't I tell you? The shear at D, when you have simply supported, this is a simply supported segment, okay, equal this over the span. 5 over 10, negative. I told you, it will go this, up, this. Okay. Minus 0.5, 0. So this is a positive shear, and this is a negative shear. يعني, but you know what does this mean? Look, عارف شو هاي يعني؟ شو يعني هاي؟ What does this mean? انت العالم اخر يعني درس جغرافيا. احسن شوي يحكيها. شو يعني هاي؟ انه اني لود هون بعطيني بوزيتيف شير. اني لود هون بعطيني نيجاتيف شير عندي. كله بنحكي عنه على دي. This is be, the dead load shear is 0. Will be 150 times half times 0.5 times 5. That's it. Half times 0.5 times 5. Fine. That's a positive shear there. How much is the negative shear? When someone asks you how much is the negative shear, say. When you do life load, بكون only here. See, construct the new place.
طب ما ليش بس حطينا ديد لود وهناك حطينا ديد ولا؟
ما راح يشرح لك شو بدي اشرح. بقول لك اللاين والديد والكاست each other يعني. زائد 200 times half times 0.5 times 5 negative. زائد 200 times half times 0.5 times 5. They cancel each other. أنا حكيت لك. 200 في هاي.
ماشي بعرف انها ماشي بتعمل كانسل بس هناك ليش ما حطينا 150 في نص 150 في نص في 5 وبرضه حطينا السالب
لأنه بصير زيرو الشير. بدك الماكسيموم شير. ديفلوب. due to this loading. تحطيها على اللي بدك اياها، بدك البوزيتيف تحطيها على الاريا بوزيتيف. أنا بحكي لك. يعني this is the bridge. If you load the full bridge, you will have zero shear. If you load half of it, you will have positive shear. You have to design for that shear.
يعني انا بقدر انه الديد لود استخدمه بس الديد لود ما بقدر استخدمه
Max. اسمع. You place the load. شو يعني بالعربي؟ بتحط اللود. To maximize. شو يعني؟ عشان تحصلي أكبر قيمة. شو يعني عشان خلاص؟ فهمت يعني؟ إذا حطيت اثنين بتقلل منها. إذا حطيت واحد بتزيدها.
بس ما تسألتش لو حكيت ماكسيمم نيجاتيف شيء بس طب شو بتفرق؟ لا يعني مش تفرق يعني انه حكيت هون بتزيد الشيء على هذيك النقطة شو يعني؟
هيطلع شيء بس قيمة بالسادس
ماينس 187. بالديزاين بفرق. لا. ايش هذا؟ هذا كان الكورس ما له اتجاه يا حبيبي يا الله. انا شغل شعري بس. يشير اتجاه؟ وين هذا الجو؟ الناس كانوا يحطوا لي اتجاه. هذا A C B. Loading we have loading all live load, only live load. Dead load is ignored. We have W live load distributed equal 0.7 kip per foot. And we have concentrated live load equal 10 kip. And the loading we have distributed load all live. Okay. Question is maximum positive live shear at point C. VC. The maximum positive live shear at point C. The maximum positive live moment at C. MC. We need the influence line for VC and the influence line for MC. And before that, before this one, put this one VC. This is MC, and the first one is RA. The vertical reaction at A. Yeah, we need what's the maximum values for RA, VC, MC caused by a distributed live load of 0.7 kip per foot and a concentrated live load of 10 kip. So you draw the influence line, you place the load to maximize. Put the load عشان you get the maximum value. Good. Now for the reaction at A, look here, طلع عينك. Right. Reaction at A, والله ما حد يفهم. تنصح. Reaction at A. We know when it's here, how much the reaction at A? 1. So we know it's 1 here. We know when it's at B, how much the reaction at A? 0. So this is like this. What's your expectation? Continue? Continue? It does. Continues. 1 and 0, we know them. This is continuous. And this one continuous. Check. If you put it here, the one is here. Okay? So you're looking for RA, right? Take some of the one equal to 0. RA times 20 equal 1 times 25. So this one, yeah, it will go up. So this is 25 over 20. 1.25. Now look, put the unit load here. For this point. 1 times 10, this one will be down times 20. So minus 0.5. Direct. Easy. 1, 0, continue. 1, 0, continue. Good. Now for VC. Any expectation? Look at VC. VC. I told you, when you have simply supported span here like this, I told you this is this. Continue. Yeah, we need to check this, but it will go this way. This is, I told you, 0.5, this. يعني here we will have VC equal.
يعني لازم يكون عندي تصور ما يكون شكله
You should know it. يعني هي تتعلم قاعد. We can check it. How we check this one? By taking a cut here. So our cut will be the following. This is RA and this is C, right? So what's the positive shear at C? This is VC, positive. Right? This is VC. And how much distance? 10 and 5. Good? So, if the unit load, look, if the unit load beyond C, after C, VC equal RA. VC
يعني ما في له. تمام.
equal RA يا جماعة. كيف ما في لون؟
لا نعم. طيب.
This is from here to here.
تمام.
أيوه بدل ما يمشي. اسمع أنا بحكي لك اللي قاعد بحكي إياه. But if the unit load is بعد C, after C, يعني from C all the way, الإكويشن تبعك VC equal RA. If the unit load is here, anywhere between this point and C, VC equal RA minus 1. The only thing we need is RA. Only thing we need is RA. Now, we know when the unit load, you start here. When the unit load is here, RA was 1.25. So VC equal 1.25 minus 1.5. That's it. Now go here, all the way here. When this one is here, how much RA? 0.5. Minus 1? Minus 1. know this. There's a jump of 1 at the point. Now the moment. A, C, B. Look, والله يطلع عليك. Look here. يعني بدي ارسم. I want to draw the influence line for the moment at C. Good. This one. And we move the unit load here, and we see what's going on with the moment at C. شو بصير المومنت at C. Now, when the unit load is here, right here, how much this one? 1. And this is 1. When you take a cut here for the moment at C, right? 0. No more. 1 cancel the 1. When the unit load is here, how much this reaction? 0. So when you take a cut here, so the moment is 0. Look, the latitude. When the unit load is here, 0.5 here and 0.5 here. اسمعني. When you take a cut here, how much the moment at C? 0.5 times 10. 5. طلع. Once you have this point, done. 0 here, so we connect. 0 here, we connect. You keep going. غشها سوي لك اياه نجيبها صح. 0.5 هاي most important. 5 and 0 and 0. So now if you want to check if it's here. يعني sometimes مش متأكد يعني. 1 here. How much this one? 1.25. 1.25. Right? So the moment here, the cut here, the moment will be 1.25 times 10, 15. Minus 1 times
15.
no, it's look, it will be
1.25 times 10 minus
يعني 15 ناقص 12 ونص 2.5 negative. Again, 1.25 times 10, 12.5 minus 1 times 15, so 12.5 minus 15 minus 2.5. Here, from similar triangles, again, this is 10. That's 10. This is minus 1, minus 5. Again, you can come here, put 1 here. So how much the reaction here? 0.5. So the moment here, wait. So the reaction will be down 0.5. So the moment here will be 0.5 times 10, negative 5. These are the influence line for the reaction at A, for the shear at C, and for the moment at C. Now, what's the question? The maximum
multiply shear at C.
maximum positive reaction. Maximum positive reaction at A. How much? A max. Max equal. How much? And where you put the 10 kip? The 10 kip on the maximum ordinate. هذا أكبر واحد. So it will be 10 times 1.25, which is 25 over 20. And where you put the live load? Only here. We don't put it here. إذا تحط هون بخف الرياكشن، بعد الرياكشن اللي تحت. So only on this one, on the positive. Plus 0.7 times 1.25 times 25 times half. Half times 1.25 times 15. 25. Good? You don't put line load here. This is the maximum reaction at A. What's the maximum up. What's R A max down?
سالب نص مضروب
Equal
10 في نص
10 times 0.5 and down one. So it's down 0.5
ماينس
minus plus half times 10 times 0.5 times 0.7.
بنحط اللون الأسمر
That's it. That's done. Second one was the maximum positive shear. Which is shear.
لا يشيل له.
Now V C max positive. Look. Only you load the areas that are positive. Which one is bigger? 1.5. So equal. What is the 10? The 10 is here or here? Maximum ordinate. 10 times 0.5 مباشرة. شو حيضرب ضرب نص. Just that. The 10 times the ordinate. Plus half times. Start with the first one. 5 times 0.25 times 0.7. Plus half times 10 times 0.5 times 0.7. That's the maximum shear. What's the maximum negative shear? 10 times minus 0.5 plus. Which one is the bigger is more? Negative shear or positive? Negative. High more negative area. يعني the maximum shear is the negative shear, which gives you tensile stress. Shear is negative. Both of them, and you take the max. بتحسب التنتين وتحط الماx. بتحسب البوزيتيف والنيجاتيف وتشويها.
احنا اخذنا لانه هاي اكبر النص لما تيجي هدول مسكت نفس الشيء باخذ بس واحد
Yes. طيب M positive max. Only this. I load only this area. What is the 10?
على 5
Here. 1.7 everywhere. So equal 10 times 5 plus half times 20 times 5 times 1.7. The unit here is in pound feet, the unit here is in pound, and the unit here is in pound. So you construct the influence line, you place the load to maximize. You place the load to maximize. The influence line for determined structure is straight segments. Straight segments. السيجمنت اللي فيها continuity يعني no change في load and the support, straight line. It doesn't change the slope. Good. أي concepts. Concepts. محمود ركز لي هون. هون. For a simply supported beam. What's the influence line for the reaction at A?
ويطلع فوق ميز
1
زلزل
and 0 here. So straight segment. What's the influence line for RB?
العكس 1
1 here, 0 here. Sum of the reactions at any point equal 1. So 1 plus 0, 1. 1 plus 0, 1. 0.5, 0.5, 175, 0.25, 175, 0.25. Sum of the reaction is 1. So what's VC? I told you, this over the length. The length is L. So L over 2 over L. نص. So when the electrode is here, 1 here, the reaction here is 0.5. So the moment here will be 0.5 times L over 2. So L over 4. Straight. What's the shear at A? The same as the reaction at A. What's the shear at B? Minus the reaction at B. Done? And for any loading, you place the load to maximize. Cantilever beam with length L. A, B, C in the middle. What's the influence line for MA? If the unit load is here, 0. The moment that A is 0. Maximum, the moment that A will be maximum, the unit load is all the way. The moment will be minus L. What's the influence line for RA? The reaction at A.
1.
When the unit load is here, 1. When the unit load is here, 1. So 1, regardless of the location. What's the influence line for the moment at C? MC. No moment will develop at C when the load is before. And this is your cut. This is C. This is the moment at C. If there is no load here, no moment. So 0 till C. After C, when the unit load crosses here, you start developing. It will be 1 times the distance from here to here. So minus L over 2. Minus L over 2. What's the influence line for the shear at C? Nothing will develop unless you